What does it mean for an exoplanet to be habitable? The habitable zone is the distance from a star at which liquid water could exist on orbiting planet surfaces, and is where conditions are just right, neither too hot nor too cold for life. What makes an exoplanet habitable? Firstly, the planet must have liquid water, suitable gravity and temperature, and lastly, magnetic field. Now, let's introduce our own habitable exoplanet. This habitable exoplanet is called Einstein 243G. This exoplanet orbits a K-type orange dwarf called Einstein 243. This star is similar to the Sun. It has a temperature of 5,145 Kelvin and is about 7 billion years old, but it is 20% more luminous than the Sun. The low stellar activity of orange dwarfs creates a relatively benign radiation environment for planets orbiting in their habitable zones, increasing their potential habitability. In this star system, Einstein 243G is similar to the position of Mars in the solar system, that is about 224.43 million kilometers away from its parent star. It has an elliptical orbit and is not tidally locked. It has the same axial tilt as Earth, that is 23.5 degrees, and has an orbital period of 526 days. Einstein 243G is a rocky exoplanet with a large iron core, a mass and radius larger than Earth's. This could provide it with a sustainable atmosphere and geological diversity. This planet receives an amount of stellar radiation from its host star that could allow the existence of liquid water on its surface. Liquid water makes up 64% of the planet's surface, and the remaining 36% consists of land, made up of various substances native and unnative to Earth. The water of the planet is hazardous to humans if consumed without treatment. The water possesses high concentrations of algae, which will consequently result in eutrophication occurring in many bodies of water, as many bacteria will decompose the algae once they have died. Trees grow over most of the smaller bodies of water on the planet. Their leaves possess a different color, which is caused by a naturally occurring dye in the leaf, which also plays the role of chlorophyll, absorbing sunlight for photosynthesis. The color of these dyes is controlled by the base sequence of DNA in each leaf. As the leaves fall down to the bodies of water, the color will diffuse throughout the water, making the algae in the water visible. The water bodies of the planet will absorb different colors of light. As a result, the exoplanet is unusually colorful, the color palette resembling that of an abstract painting. As previously mentioned, the land is composed of various substances native and not native to Earth's own land. Unlike Earth's crust, the most abundant element is silicon, followed by aluminum, iron, and sodium. Due to the smaller percentage of land, there is a larger average concentration of mineral ions in the soil, so the plants on the exoplanet grow more exponentially than Earth's. The terrain of the planet is also similar to Earth's, but slightly more extreme. While there are many mountain ranges, canyons, valleys, and cracks, they are evenly distributed throughout the planet. There is also many flat pieces of land at sea level, where the highest concentrations of plants are located. The highest peaks of the planet are estimated to reach 9.1 kilometers, and while the lowest depths of the planet are unknown due to the limitations in oceanic exploration, they are estimated to go over 11,000 kilometers. Not much life is present in the shallower areas of water. Only ones present are microorganisms, coral, and small fish. The bulk of the marine life dwell at the same depths as the twilight zone of our own oceans. Einstein 243G has an average temperature of negative 32 degrees Celsius, the coldest being negative 116.1 degrees Celsius, while the hottest being 45.85 degrees Celsius. Its gravity is stronger than Earth's, as it has a mass of 1.15 Earths. Its atmosphere consists of 80% nitrogen, 19.1% carbon dioxide, and 0.9% argon. As there's no oxygen in the atmosphere, living there will be difficult. However, we have created a potential habitation plan for this exoplanet. Parts made of durable and insulating material will be used as houses. These parts can be deployed or built on both land and sea, allowing for much versatility. 2 years' worth of oxygen tanks will be provided for the inhabitants of these parts, so they can survive while waiting for plants that were brought to fully grow and be able to perform photosynthesis. They will release oxygen and make the planet's atmosphere suitable for humans and Earth-based life to grow. Large amounts of trees and other plants should be planted in order to produce oxygen for living beings to breathe in. And that, ladies and gentlemen, is our own concept of a potential habitable exoplanet. Of course, this is just one of millions of ideas what a habitable exoplanet might be like. Who knows what kind of super Earths we might come to discover soon that could possibly secure our future. With future discoveries, these concepts and ideas will be subject to change. I hope that our video gave you a glimpse into the possibilities of planets that could be out there in the vast unknowns of the universe, waiting to be discovered.